I'm Elliot. I'm a software engineer at Crown Equipment. You'll probably know us as the guys that pick things up and put things down. I've been programming in Python since 2009. And if any of you older folks remember a small red-headed kid at the 2010 Kiwi PyCon, that was me. Okay, well, let's get packaging. This talk is going to cover a few things. First, we'll briefly discuss the problems that we encounter from treating Python packaging in a laissez-faire or free-for-all manner when you sudo pip install here, sudo apt install there, etc. Second, we'll take a quick look at the wrong solutions, which is to throw random packaging tools at the problem to make it go away, irrespective of whether or not these should be used at the same time or if they solve the right problem, something I just like to call sculling the entire medicine cabinet, where you hope that drinking as much medication as you can will solve your problem and not leave you many times worse than you were before. Third, we'll discuss why the best/laziest tool of all that gives you the least number of headaches is Rye. And finally, we'll jump into the good stuff, which is actually using Rye to solve our packaging problems. Now, for those who don't know, Cargo is the build system and package manager for the Rust programming language, and it does just about everything. If you want to build, you type cargo build. If you want to run your package, you type cargo run. If you want to add a dependency, you type cargo add my dependency, and so on. It really is that semantic, and that is a good thing. Not only does it do everything, it is also a standard. That means everyone uses it, which is also fantastic. Okay, now let's look instead at Python. Now, I did like Clinton Roy's PyCon talk in 2015 on poetry, so I've liberated his XKCD comic for this talk, and some of you probably know what I'm talking about. Maybe you have Python installed in one place, but another instance elsewhere, and it becomes a hassle figuring out which one is doing what you want. If you're installing Python using Homebrew, chances are you're doing something wrong. If you are a beginner, there is a lot of advice on how to get started and which tools to use. Much of this advice is bad advice or just simply out of date. So, we arrive at a simple question. Is there a way that a beginner can start with Python package management such that they will stick to it when they are old and grey? I want to make sure that if you are relatively new to Python and lost when it comes to what packaging is, you know what I'm talking about. When I say import package, I'm talking about a folder which contains modules and or other sub-packages, import sub-packages beneath it. When I say distribution package, I'm talking about a bundle of code that can be shared easily. A distribution package will generally contain its own import packages beneath it. And finally, when I talk about package management or managing your Python project, I'm not specifically talking about either of these two things, but about handling a Python project more holistically. We'll talk a little more about what that involves soon. Now, it is true, if you are disciplined, then a vanilla experience can be very reliable, albeit verbose and time-consuming. There are an array of other tools out there. In 2017, we got pipenv, which was to help get deterministic builds quickly. Now, unfortunately, it doesn't take advantage of pyproject.toml and has diminished somewhat in popularity since. Pyenv doesn't support Windows, meaning it lacks universality. Poetry, which is wonderful in many, many ways, it handles many things, though it can't handle Python versioning natively. It also doesn't populate pyproject.toml in a PEP-compliant manner. Now, there are many other tools out there which serve different needs, and some of them seem great, but are too arcane for a beginner and cause too much confusion. While there might be a set of options that works very well for you, that doesn't mean it will work well for others, especially people who are new to the concept of Python package management. For a long time, Python developers have lamented the absence of a cargo-style, PyPA-sanctioned all-in-one solution. Most of us can attest to some confusion around which tools to use when we first wanted to create our first packages. As so many promoted tools have overlap in terms of what they do, it is not always obvious that two promoted tools will work in conjunction with each other. Will they play nicely with each other? So what do we want out of a Python development all-in-one tool? Okay, first, Python version management. We should be able to use specific versions of Python depending on the needs of our end users. Maybe they can't use the latest version of Python, and that is the case for many people. Creating virtual environments. We need to isolate our dependencies and not pollute other projects, like default venv does. Managing packages. We should be able to install dependencies into our virtual environment, just as pip does. Package building. We need to generate wheels or source distributions to share our code with other users, as setup tools does. And finally, package publishing. We need to make our code available to other users, like we do with Twine. Now, I'm not going to give you a full overview of all the options out there, though Annalena Popkes gave a very good talk on the subject last year at PyCon Germany. This is her Venn diagram here, showing the jumble of tools that have been popular over the last several years. There in the middle, you can see the two tools that provide a holistic approach to package management in Python. Those are PyFlow and Dry. And in case you are wondering why this talk doesn't concern itself with PyFlow, the short answer is that it hasn't undergone development in 3 whole years, which in the world of packaging makes it obsolete. So yes, there in the middle, we find Dry, the modern packaging tool that does mostly everything. Now, an important disclaimer. Dry has not yet received an official endorsement by the Python Packaging Authority. However, they don't have yet the resources to develop a modern tool at the rate that some third parties are able to. So yes, Dry is yet another tool in the mix, but it is becoming very popular very quickly and has backing from the same people who maintain the rough linter formatter and the UV package installer. I'm sure most of you, if not all, have heard of that just today. Dry has undergone tremendous growth despite being the new kid on the block, and reception has been very largely positive. If you're still hesitant to make the switch, I encourage you to start a simple project with it and see just how quick it is to get started. So without much further ado, I'm going to jump onto VS Code. There we go. And zoom in. Can everyone see that? Perfect. Not really, I'll go one step in. How's that? All right. Just a heads up, even though Rye is a Python development tool, it is in fact written in Rust, so you don't need to have Python already installed to run it. In fact, the machine I'm going to be using doesn't have Python installed on it right this second. For Linux and Mac users who want to install Rye, you need to write a simple shell command, and for Windows users, you can download the releases from Rye's website. I'm currently shelled into a Linux machine, so I'll use a simple command to install Rye. Bada bing, bada boom. And continue. Now we'll be prompted to choose the package installer because we don't install any distribution packages for our projects without first interfacing with Rye. Rye sits on top of other tools under the hood and delegates tasks to them as needed. Since February, Rye has allowed us to use UV, so we'll choose that instead of pip tools. I talk about why, but that would be better suited for a different talk. Now, you are able to decide whether or not to set up global shims, and if you already have a project relying on other tools, it might be wise not to, but otherwise you can go right ahead. If you don't know, shims serve you a Rye managed version of Python wherever you are, when you type in the Python command. So very simple. Now I'm happy enough for the latest release of Python as my default, and just like that, it's installing. Bingo, okay. Now it sets up the shims for us, which is quite a recent development. I had it written here to set them up in front of you, but I don't even have to, which is terrific. Now you might not have this directory already put in place, but that's a directory there for you Linux users, into which you can put the output. Whoop. I'll get this right. Here we go. Rise self-completion. That just gives you tab completion. Just another thing to make your experience much easier down the line. So I run that. Already done. Okay, and there we go. Already auto-completing. So we're all set up with Rye, and we have an instance of Python now installed. We're all ready to create our first project. So let's type in Rye init pottage. All right, we've created our first project. Let's take a look inside. Okay, you can see there that there is a Git repository already initialized for us with a pyproject.toml file for defining our project. If you are still using setup.py in your own projects, that is a likely sign you are overdue to revisit some of your packaging practices. In here, we place all the important details about our distribution package. Let me just open it up. As well as information about how our development tools are to use our package. So you can see up there, here's some of the metadata. Hopefully a lot of you will be familiar with this, but it's okay if you're not. Now down here, there we go. This section is Rye specific. Because this tool is managed, this project is managed by Rye, we can use Rye to perform all the important packaging tools or tasks on the project. After that, you can see an empty array of development dependencies. At the moment, in Python, there is no universal standard where these should go. So Rye tells us just to put them in here for now. That may change in the future. That's okay. All right. Now, looking back at the repository, we've also got Python version 3.12.5. That's the version we downloaded. It's already set up by default. We can change this, but we'll get to that later. And finally, I'm going to ignore the README. We go into source. The source directory, as you can see, contains the import package pottage, wherein our Python code is stored. For reasons we won't get into today, I encourage you, in as much as you can, to maintain this convention of keeping the source folder in the project root and any import packages beneath it. If you have an exception, you'll know why, but otherwise stick to this. All right, inside source pottage init, let's take a look. We've got a function ready to use. Hello from pottage, perfect. Okay, suppose we wanted to import this function. We might think that we type in, no worries, Python, cool beans, we've already got a new virtual environment. Let's try importing. Import pottage. Well, no luck. Module not found. Okay, the reason for this is because we haven't yet installed our package. Normally you would install the local directory as an editable, but with Rye, we don't actually have to worry about that. So let's just jump out, and then all we do is Rye sync, and we are done. This will not only create the virtual environment if you haven't already done this, but it will install all our dependencies, including the import package we just made. Now, we try. Python import pottage, pottage.hello. There we go, already. With no effort just about, we have successfully created our first import package. Now we can go one step further. Let's create an entry point. Now, some of you may or may not know you can do this, but you can go domain.py. I go import pottage and print pottage.hello. And then we can test it. Python -m pottage. Hello from pottage. All right, that was super easy. All right, next. Yep. So you'll have a different configuration on Windows if you don't have developer tools enabled. So that's just a warning. I've been there. It's not particularly fun and it's slower. But here on Linux and the land of the free, I'm enjoying something very nice and fast. Okay, so we've demonstrated we can create a virtual environment with Rai and shown how easy it is to use. Now let's show the potential of Python version management. Let's see the Python versions we have available to use right now. Rai toolchain list. Okay, there's the one that we had by default when we installed Rai. Now let's see what we actually have in use for our project. Rai show. Okay, we have a virtual environment that has Python 3.12, but also we're saying, as you can see above that we want this repository to work for people who are using 3.8 in our project. Okay, well, how do we avoid, for example, introducing something in 3.12 by accident that doesn't work for those users, such as dictionary unions? Okay, this is where it's useful to set the particular version of Python we wish to use to avoid making this mistake. Let's go, Rai pin 3.8, Rai sync, and it's already downloading the correct version of Python. That easy. It really is so simple. Now let's just double check everything is working the way we expect. Whoop. There, 3.8.19. Perfect. Now let's move on to managing packages. Some of you are likely familiar with the concept of lock files, and some of you may be less so. Let us suppose we wanted our project to use the latest version of Pydantic. We go. Let's just clear that out. Rai add Pydantic. Okay. You'll notice that a number of distribution packages were installed besides Pydantic, so annotated types, Pydantic core typing extensions, etc. Now, where are these in our project definition? We might think we go into pyproject.toml, but there is, if we scroll up, Pydantic, just as we defined it with a minimum version of 2.8.2. We don't see the other packages. Why is that? Well, these are actually kept elsewhere, because when we run Rai sync, pyproject.toml specifies which versions are acceptable, but then Rai sync also installs what we can use best for our project depending on the constraints we've imposed. Let's look at requirements.lock. There we go. Because Pydantic has its own dependencies, Rai, using UV under the hood, has attempted to find the best possible combination of distribution packages needing installation to support Pydantic at the version restrictions that we specified. I won't demonstrate here, but you can also add development dependencies using Rai add --dev, which will affect the requirements-dev.lock file, but not the requirements.lock file. Very, very easy. Now, if you are familiar with pipcompile, this shouldn't look too unusual to you, but because UV is written in Rust, it's seriously fast. Now, going forward, we may decide that we wish to publish our code as a distribution package. You don't have to if you're doing all this, but it might be a good thing to do. The great news is that Rai lets us do that without any trouble. Under the hood, it uses the hatch backend by default, but if you like setup tools, you can use that too, and there are other options as well. So let's now make a wheel. Rai build. Done. That quick. ls, whoop. Let's take a look inside the distribution folder. So there on the right, we already have our source distribution, all bundled, and there on the left is the build distribution, the wheel, which is specific to Linux in this particular case. Now, if you ever spent a large amount of time trying to figure out how to get a single Python package to be packaged in the first place, well, there is good news. Packaging in Python is not perfect, but we are in a much, much better place. We are leagues ahead of where we were 5 or even just 2 years ago. Now, I'm not going to show you how to publish, but if you've published packages with Twine before, then using Rai publish is no more difficult, and is one fewer tool that you need to install. Nice. Before we finish up here, it would be nice to show you some of the other features that make developing Rye projects such a smooth experience. So, scripts are nothing particularly new, but let's demonstrate how easy it is to add one just quickly. First, let's add another function. So, vim, and we'll go into init, dunder init. There we go. And add def minus, return, no, we want print 3 minus 2, and close that. And now we can expose this with an entry point in pyproject.toml. So let's go do that. Here we go. Now all we add is project.scripts minus equals, to get this, pottage, minus. All right. Before we run our command, we want to make sure that the changes we made are locally installed, because this is a modification of the package itself. So we go rye, sync, all done. Now, as many of us will know, we can activate the virtual environment and then run the command. So bin activate, and then we go minus. Okay, nothing too special. Nice if you haven't seen it before, but for a lot of you that's not new. What you can also do is just go rye run minus without it activated. You can do that from anywhere in your repository, which is very handy, especially if you don't want to find the location of your virtual environment and activate it. So that's fantastic. Now suppose that you want to create a command that helps with building or whatever it may be, and you don't want to expose that to your end users. Well, Rye has something for that too. So let's go into pyproject.toml and just undo this here. Whoop. We'll go down and add a Rye script. This is going to be specifically for our Rye developers on the project. So, scripts, and we're going to go minus equals, call equals, pottage, minus. All right. Now you might think that let's go Rye sync and then activate the virtual environment and then try and run the command, but you're not going to get it. This is only for Rye developers, people that are using Rye in your project. So Rye, let's in fact just deactivate that. Rye run minus, and there we go. All right, perfect for anyone that's maintaining the project if you don't want to clutter all the commands available to your users. Scripts can be execution of Python modules, but they can also be shell commands, or they can use environment variables, so they are generally very flexible. At no point in this project, you'll note, have we used pip directly, or as it happens indirectly. Now, before I hand it over to questions, there is one big disclaimer. Let me just clear that. There is one big disclaimer. Rye was started by the creator of the Flask web framework, and he's since passed on the baton to Astral to maintain the project. Now, UV was started by Astral in the hope of also providing a universal package manager experience. And though it is far from that yet, it is expected at some point in the future to replace Rye. You know, similar commands, etc. So it's not going to be hard to pick it up. But that's what's going to happen. This isn't going to happen overnight, mind you, but given the close collaboration between Astral and Python developers, I would wager that the transition will be smooth and very well planned for your convenience to make it very easy to switch over. So, what should you do? What should I do? Start using Rye. Do use Rye for your next project. I think you'll really like it. And so, without much further ado, I will open the floor to questions. Yep.
Yeah, thank you, Elliot, for the insightful talk. On your anecdote at the end there, what do we do now that Astral came out with a blog post 2 or 3 days ago saying UV is now feature complete and comparable with Rye and intended to replace Rye?
You don't know that yet. No one knows that yet. But presumably, at some point, you would replace tool.rye managed equals true, likely with something like tool.uv managed equals true. We're not talking about a complicated switchover. These are the same people working on these projects. So they are going in, especially given if you take a look at GitHub, the issue pages, you'll see that every engagement has big thumbs up everywhere. I've never seen it so positive on, but rough, UV, Rye, those all have massively positive receptions. So I would say, yes, if it were another developer taking over, I might be worried, but I'm willing to say that it's going to be a pretty smooth transition.
It wasn't meaning as a negative thing, but more that now that UV is as feature complete as Rye, would there be any reason to use Rye compared to just starting with UV? If UV is going to be where we end up now that they have the same amount of features.
Are you saying they already do?
They came out with a blog post 2 days ago saying they do.
Rye 0.3.0, as of last time I checked, doesn't do everything. It does do more things than it used to. So someone might say, hey, here's my demonstration of things that you've done just now. But that's great if it does, and it will likely be the same commands that you're running. So you'll be doing UV, add, UV, etc. And those things already do exist, but for all the other commands that we've shown, like using Python versions and finding out what's there with Rye show, Rye toolchain, Rye self-completion, all those things, those will be made available at your convenience. So I don't know if it's got all of those just yet, but at some point that's happening.